A fishing rod weighing under 1 pound, yet capable of controlling sea creatures that weigh hundreds of pounds.
That strength doesn't come from luck or the skill of the angler. It is shaped inside the factory, where every material layer, every fiber angle, and every processing step is tightly controlled to determine how the rod bends, transfers force, and responds in real-world conditions. At first glance, a fishing rod appears small and simple. But behind it lies a massive industrial production system operating continuously on a global scale. The global fishing rod market generates nearly $2 billion in revenue, serving everyone from recreational anglers to professional sport fishing competitions.
In terms of volume, more than 100 million fishing rods are produced and circulated worldwide each year.
With major demand concentrated in markets such as the United States, Europe, and Australia, what surprises many people is that modern fishing rods are no longer made of bamboo, as is often assumed. Today, most fishing rods are built from carbon fiber, a material originally developed for the aerospace industry. Yet what truly sets them apart is not the material alone, but the precise way each structural layer is arranged and controlled through a manufacturing process, accurate down to fractions of an inch. The primary materials used for the rod blank are carbon fiber prepreg and fiberglass prepreg, fibers that are already impregnated with a heat-reactive resin. This resin is designed to harden when exposed to high temperatures, but if it remains in normal ambient conditions for too long, it can begin curing prematurely and turn into waste. Because of this sensitivity, all prepreg materials are stored in cold rooms at temperatures below 32 degrees Fahrenheit and only removed at the exact moment they are needed for production. As soon as the prepreg is removed from cold storage, the clock starts ticking. The material is unrolled and laid flat onto the cutting table, following every technical outline provided for the engineering team. A technician measures by hand, carefully aligns the material edges, and then the machine executes each pre-programmed cutting pattern with control precision. Each cutting cycle can at the same time to maintain productivity, yet accuracy must still be preserved down to fractions of an inch. Carbon is rarely cut in straight lines. Instead, it is shaped into triangular forms or diagonal patterns. This cutting geometry controls how force travels along the length of the rod when it bends under load. A single piece cut off by just a fraction of an inch can shift the rod's flex point entirely. Next, the material must be positioned precisely onto the mandrel, a stainless steel shaft that serves as the internal forming mold for the rod blank. The mandrel is typically treated with a non-stick release agent so that, after heating, the finished blank can be separated cleanly and without damage.
Once adhesive is evenly applied along the steel shaft,
the technician uses a small heated iron or a localized heating tool to hot tack the first layer of material into place. Each carbon piece is aligned carefully along the mandrel's center line, squared at both the tip and butt ends, and only then secured.
if the first layer is off-center, the entire rod blank that follows will inherit that misalignment.
There are no robots or laser guides involved at this stage. Everything depends on the technician's trained eye and experience. The moment the mandrel is placed onto the rolling table is when the rod truly begins to take shape. The machine rotates at a slow, controlled speed,
while each layer of carbon fiber is wrapped around the steel core entirely under the craftsman's command.
From rotation speed and hand pressure to precise stopping points, and the exact instant the next layer is laid down. As the core turns, the fiber layers tighten against one another, the material edges close cleanly, and the rod gradually. After the main layers are complete, the technician adds reinforcement layers at high stress zones, especially near the handle area. These reinforcements are not applied simply to make the rod thicker or stronger, but to fine-tune how it feels during casting and while fighting a fish. Once all carbon fiber layers and reinforcement plies have been fully wrapped, the rod blank moves into the heat-resistant tape wrapping stage. The factory uses nylon tape, cellophane tape, or specialized vinyl tape to tightly bind the entire blank before thermal processing. The mandrel is mounted onto a wrapping machine, and as it rotates, the tape is applied in a continuous spiral,
with each pass overlapping the previous one under consistent pressure from end to end.
The purpose of this step is to lock the rod's shape in place and keep every carbon layer pressed firmly together throughout the heating cycle that follows. As the tape tightens, the material beneath is compressed evenly, creating a uniform wall thickness along the entire length of the blank. At this stage, the mandrel acts as the internal mold,
while the tightly wound tape functions as the external mold, holding the structure stable as it prepares for curing.
After being secured with heat-resistant tape, the mandrels carrying the rod blanks are hung onto racks and moved into the curing oven.
The oven is typically set to around 284 degrees Fahrenheit, with higher temperatures adjusted depending on the specific model.
The heating cycle is tightly controlled by computer systems to ensure the temperature rises evenly and remains stable throughout the process. The curing phase usually lasts about 2 hours, long enough for the heat-reactive resin to fully activate and complete its transformation. Inside the oven, the resin begins to flow, spreading evenly between the carbon fiber layers and bonding them into a unified structure.
What were once separate layers now merge into a rod blank that is nearly monolithic.
Before curing, the blank can still be removed and adjusted if necessary. But once the thermal cycle is complete, any prior deviation becomes permanently locked into the internal structure. For this reason, factories enforce extremely strict control over time, temperature, and oven stability during this critical step. When the heating cycle ends and the rod blank begin to cool, the mandrel extraction stage starts. The blank is transferred to a dedicated separation machine. The metal mandrel inside is clamped firmly by a holding mechanism, while a pneumatic pulling arm applies a steady and very powerful force to draw the core out of the rod. The pulling force must be strong enough to overcome friction, yet smooth and precisely controlled to avoid deforming the carbon structure that has just finished curing. If the earlier heating process was executed correctly, the mandrel will slide out cleanly, leaving a completely hollow rod blank. If there were any deviations, extraction becomes difficult and can damage the surface. Extraction becomes difficult and can damage the surface. At this point, the technician performs a quick inspection of straightness and uniformity, relying entirely on trained eyesight and tactile feedback built through experience. Once the blank has fully cooled, surface finishing begins with the removal of the outer wrapping tape. The technician peels the tape off following its original spiral direction, unwrapping it continuously from the tip to the butt of the rod. As the tape comes away, the blank is revealed with spiral marks, small ridges, and a rough surface formed during the compression process. From here, the blank is moved to the cutting station for final length shaping. The technician places the rod onto a support fixture, aligns it precisely along its central axis, and feeds it into the machine. The cutting blade rotates at a steady speed, removing excess material from both ends with accuracy, bringing the blank to its exact standard length. Once the dimensions are set, the blank enters the grinding and sanding stage. Dry sanding comes first, breaking down larger ridges, smoothing sharp edges, and removing surface marks left by the compression tape. The technician rotates the rod evenly by hand to ensure uniform treatment around the entire circumference. After that, the blank is wet sanded.
Water reduces friction, carries away resin dust, and allows finer control over sanding pressure.
After surface finishing, the rod sections are moved to the joint fitting area for alignment inspection. The technician inserts the tip section into the butt section in the correct orientation, then gently twists and shakes the assembly to feel the tightness of the connection. A joint that meets specification must engage evenly, with no looseness, no play, and no sound when moved.
Because a deviation of just 0.04 of an inch at the joint can completely disrupt the continuity of force transfer, this check is critical.
Quality control starts right here on the factory floor. Every single rod blank is inspected and bundled with precision by our skilled team.
These bundles are then secured neatly and sent to the painting workshop. After surface preparation is complete, the rod blank is transferred into the paint shop. The blank is mounted onto a rotating machine that applies paint evenly around the entire circumference. The first layer is typically a white coat or base primer, used to unify the surface and enhance color vibrancy in the layers that follow. Once the base coat has dried, the blank receives its color coating. Fluorescent paints are commonly used at this stage to improve visibility during outdoor use, especially in low light or over water. Depending on the order, the rod may also be customized to meet specific customer requirements. The process concludes with a clear urethane top coat. This final layer is sprayed or wiped on evenly to create a smooth finish that resists scratches, ultraviolet exposure, and saltwater moisture. After application, the rod is placed into a drying room, allowing the coating to cure and stabilize before the product moves on to the next stage.
After the painting process is complete, the rod blank is transferred to the handle assembly area. Here, all handle components are installed entirely by hand.
The technician applies adhesive along the blank, then carefully slides each handle section into its designated position according to the design.
Depending on the model, handle materials may include EVA foam, cork tape, or heat shrink tubing.
Next comes the installation of the reel seat, the component that secures the fishing reel. This part must be aligned perfectly along the rod's central axis, because even a slight misalignment. Once the reel seat is fixed in place, the butt end of the rod is finished with either a butt cap or a gimbal.
At this stage, the blank is no longer just a smooth composite tube. It begins to take on the shape, balance, and tactile.
After the blank has been painted and the handle installed, the guide installation stage begins. First, the technician marks each guide position along the length of the rod according to the design layout. These marks determine how the fishing line will travel and how load will be distributed along the rod during use. Each guide is placed onto its marked position and aligned by eye along the rod's central axis.
Once the position is correct, the technician begins wrapping thread around the guide foot.
One hand holds the guide steady, while the other wraps the thread evenly and tightly to secure it to the blank. Every wrap. After all guides are wrapped, the technician performs a final visual check along the entire guide line, confirming straightness and balance before
Down the barrel of the guides, alignment is checked. It is this intense focus and methodical craftsmanship that defines our process.
After the guides have been secured with thread, the rod moves into the epoxy coating stage. The technician uses a brush to apply a base layer of epoxy over each wrap, making sure the resin penetrates fully into the thread and bonds firmly to the rod blank. Once the base coat reaches the proper level, the rod is placed onto a rotating rack or turning drum, allowing the epoxy to level itself evenly around each guide. Next, the rods are passed through hot airflow or an ultraviolet curing chamber. Heat and ultraviolet exposure partially cure the epoxy. After this initial set, a final epoxy coat is brushed on to create a thicker, glossy, and durable surface. Extensions. In a single day, the factory consumes a very large volume of finishing material during this stage. Each drying, the worker monitors the massive spinning racks, ensuring no drips form during the long curing hours. After all assembly stages are complete, the tip section and the butt section of the rod are joined together for the first time. The technician inserts the tip into the butt in the correct orientation, then applies a gentle twist to check the fit of the joint. The connection must engage evenly, neither loose nor tight, and slide smoothly throughout the entire insertion range. Once the two sections are fully seated, the rod is placed on the inspection table to check axial straightness. The rod is then flex tested under a controlled load to verify overall strength, balance, and structural stability along its entire length.
The hum of the testing machinery is audible beneath the upbeat music as the red numbers climb.
Finally, The entire rod is wiped down to remove fingerprints, dust, and any excess adhesive residue. The surface is examined one last time under strong lighting to detect scratches or minor imperfections. When all
polished to perfection and sealed with care. Ready now for the open ocean. The worker fastens the final brand tags, marking the completion of the arduous manufacturing journey.
To glue for this fan. When holding a fishing rod in hand, what an angler truly feels is consistency in every response. That consistency is what determines whether a rod can be trusted in real-world use. If you want to continue exploring the industrial processes behind everyday tools like this, like the video, leave a comment, and subscribe to